Hi, so my name is William Benford. This is going to be my screencast for Project 4 for operating systems. At long last, we're almost done. So of course, to go over this project, we're making a device driver for a virtual joystick. So I have my driver open on this command prompt here on the right. It's a couple important libraries you need. First of all, in order to interface with the USB subsystem, we need this libusb-1.0/libusb.h. Took me a long time to figure that out. That was driving me crazy for a while. We also need a number of libraries to help us interface with the Linux input systems. That includes uinput, includes linux/joystick.h, includes linux/input.h. Some of these are just defining some numbers, which makes things a little bit easier to use. But most of the functions that we need are in uinput and then in libusb. So first of all, it's a little bit messy, so I'll walk us through here. So first of all, you want to connect to the device. The virtual device here, and so we're using libusb to do that. First, we have to initiate the session. This is what's this doing right here. The next thing of course, there's a lot of checks and just checking for failures and returning early if we need to. So that's what this here. It returns less than 0 if we haven't initiated correctly. Going on, we set the debugs that there's problems, we can see them a little bit easier. We get a list of all the devices. We open up the device which we're given. We know that the vendor ID and the product ID are these two numbers right here, so that makes it easier to open up the device instead of having to search through the whole list. We have an error, of course, if you can't find it. That typically happens. If it's not null, then I'm telling us to open it. Otherwise, this line will throw an error that was unable to open up the device if we haven't set it up correctly. We free up the device list because we don't need the whole list anymore. We just need the device that we opened up. We make sure that the kernel does not currently have access to it, which it shouldn't, but it's just in case. And we're going to claim it as this one being the driver that's going to be used. All right, and so that's setting up the The next thing we need to set up is writing out back to Linux. And so we have this uinput file that we use to write to. It took me a while to realize that we weren't writing to JS0 rather than we use uinput. You have to be kernel level in order to go to JS directly. Then we have these IO control functions. This is just setting up the events that are needed. So we have an event key for the button. We have an event absolute for the two accesses that we need to. And then we have some additional settings for the events themselves. So the key bit that we're using is button trigger. And then the absolute bits, we need the X and the Y axis, of course. And then we also, lastly, there's a further event we need for the synchronization event, which will actually, I think is what actually triggers the events and helps JSO actually read from the thing. So anyways, so the next thing we have this struct for the settings for this is mainly for users. I'm pretty sure these don't have an actual impact on the functionality. So we have a name, we have the bus type, we have the vendor and product ID, we have the version of the driver. We also have minimums and maximums for our absolute accesses, which are defined the project as being negative 32,767 to positive 32,767. We're going to write these settings to the file up here. So of course the file being dev/uinput. Continuing on, we're going to sleep just to make sure that everything is written properly. This is just a safety mechanism. And then we have this loop. So we're going to start reading from the device and outputting the results to as events to uinput. So first of all, we read from the device. It's an interrupt-driven device, so we have this interrupt transfer function to help us do that. The endpoint code is OX81, which I found with the function was called, I think it was LSUSB, which listed information about each of the devices, and that's how I was able to find this number right here. The rest of it is, just to help run it. We have gathering the information from it. So of course it's all held in 1 byte, so we have to do some bit shifting and moduluses in order to extract the information, and then we're going to map it to the expected output. So for example, for the x-axis we have 1, 2, and 3. We want to turn that into the numbers that the final input is expecting. With the y, it's kind of flipped. So 1 is actually down, so that means that it's negative. And going on there, so that just lets it be in the correct orientation there. So continuing on here, we have the input events, the actual input events. So we can write an entire array all at once. So we're going to set up the button, the x-axis, and the y-axis. very similar. We have the event type, we have the event code, we have the value, which we calculated earlier. We write it to the file, but this doesn't actually do anything unless we've actually done the event. This bit right here is just for testing from earlier. So we actually have to send a synchronization event as well, so that's what this is here for. And then we sleep temporarily so to make sure that we're not hogging up all the CPU space. We're going to run this as often as we possibly can, and hopefully have a decent results there. So moving on to the testing phase, of course, we're going to launch the virtual joystick. We're going to connect it to the USB system. We're going to run the driver, which I'll rename the executable when I'm actually submitting the project. And then, of course, we're going to run our test so we can see all the results. So we see that if we go up, we have positive number, then it translates to 0 when it's either down or up. And down we have negative 3276. For the left, we have negative 32767. Positive for the right, 0 with off, and then button is off, and then button is on. Of course, these react with decent latency. It's about as good as I can get it. I think it might just take time to be able to read from a virtual device, because my program's run just about as fast as I can go. Yeah, and so that's the part. So all that's working well. My virtual machine itself runs pretty slowly, so I'm not going to test the Gaterator and show that on the screencast. But I did manage to open it up eventually. It took me like 10 minutes, and it seemed to be working properly there. So that's the screencast, and that's it. All right, just a small addendum because I think for some reason it lost the change. The y-axis needed to be flipped in order to correspond with this table right here. So when it's positive and it's 3, then it's negative. So I just had to switch those signs real quick. I'm not sure why that didn't store. But yeah, now that's it.